So if we look at question one, how many electrons do y'all add up?
26.
Everybody okay with adding up the electrons? Who's with 26? Who's the central atom? AF. All right, so AF is in the center. Now, some of you from glancing at your homework, which is why I kept stopping and looking at it, not to check to see if you drew everything, because I can do that in a glance. I wanted to see how many atoms you drew and where your bonds were to get a sense of how many of you had right answers and how many of you had wrong answers. Some of what I looked at was stellar. Some of what I looked at, no offense, was jacked up. So, how many eyes are we drawing around the AF? Three. Some of you don't have even the right number of elements drawn around your central atom. Yeah, you look at this. This says 3 eyes. You might only have 3 eyes drawn around it. Okay? So when we're going over the homework in a few minutes, and I have drawings drawn up here, and for example, one of them says Cl2O, I think it was. They had one O, and it said what?
Oh, no.
Okay? And one, somebody's paper, I can't remember who it was, had 3 Cl's drawn around it. Then you have 3 chlorines drawn around the O when it says Cl2O. No, there's only 2 chlorines. So you can't have 3 of them. Okay? So when you look at the formula and it says 3 eyes, you are only allowed to have 3 eyes. Okay? Now, when I draw in my electrons, what's the question, Alexis? Okay, so I'm going to draw in 26 electrons. First of all, I'm not drawing in any multiple bonds. Some of y'all have 4 lines drawn in here, or 3 lines. Don't start with a multiple bond. Okay? Start with all single bonds. After you've drawn in a single bond, then look to see if someone doesn't have 8. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Got wrong. 26. Okay? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I still counted wrong. 24, 26. There we go. 26. Now, once I put in all 26 dots that I'm allowed, now go back and check to see if everybody has what? 8. Does everybody have 8?
Yes.
So do I need a double bond here? No. So I'm not going to try to put in a double or a triple bond here because I don't need a double or a triple bond here. I'm always going to start with all single bonds and see if somebody is short electrons before I try to put in a double or a triple bond. Does that make sense? Okay. Now your question, Alexa. Okay. So the next one. CBR4 had how many dots?
33.
Who's my central atom? All right. So is everybody okay with those 2 things? 32 electrons and C is the central atom. All right. So how many BRs am I drawing around my C?
4.
Everybody's okay with 4 BRs? Okay. So when I do that, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 30, 32. So, did everybody wind up with 8 when I drew my 32 dots? So, do I need to worry about a double or a triple bond here? No. I'm good to go on this one also. Everybody has 8. There is no need for a double or a triple bond. Everybody has what they need. So are we okay? Okay. Now, the last one, H2CO, has how many electrons? All right, I hear 12 from Nathan. 12. We agree on 12. Okay. So, this time, I have how many that have a single atom? So how do we decide if we're going to pick C or O? Who's farthest left on the table? Carbon. All right, so if I put C in the middle, I'm going to put what around the C? All right, so I got two H's and I have an oxygen. So an H here, an H here, and an O. It doesn't matter what goes on what side of the C, just somewhere around the C. Now, from there, I get how many electrons? 2, 4, 6, 8. Who did I say yesterday? Never, ever got dots. 8. Okay? So who am I going to put these extra dots on there? Oh. So there's 8. And you said we had 12, right? So 10, 12. Now, some of us have a misconception about H based on my homework examination. This H here cannot have any double bonds, any triple bonds, or any dots. We said yesterday that H had a configuration of 1s1. S can have a total of how many electrons in it? 2. H only gets 2 electrons. You see that line? That line represents how many electrons? That's all it gets. Nothing else. So, if it can only have 2 electrons, are we going to try to get it 8? No, it's an exception. It's not getting an octet. Okay? So what I told you about yesterday is not getting an octet. Getting 2. It's happy. It's got its 2. H has got its 2. So who are the only 2 atoms up here who are getting 8? C and O. Does C have 8? It's happy. Does O have 8? It's not happy. How are we going to help it out? It's got to share. So, C has 8. O doesn't. C's the one who has to share. So, what are we going to do to help C share with O? Double bond. So, O's or C's are going to take these 2 right here. I'm going to share them with O by putting them where? Right there. Question. No. The answer to 4 lines is no. There are no exceptions to that either. 4 lines is a no. Everybody hear me say that? There are no 4 lines ever. Okay? There are never 4 lines. Okay? Let's talk homework. All right, there are the answers to homework. Again. Okay, in a minute. Oh. Oh my God. I got double phone. Don't do. And I double phone. Oh, I'm Laura is the only other one of these. Third base?
And we're stepping to the side, I think you were tired, but always like after the third one, you thought. You would sing happy birthday? Oh, no.
We are beside the chorus class, let's not. I was gonna say, if you're gonna let Emma sing happy birthday to you, feel free. The rest of you people be quiet.
Happy birthday to you. Happy birthday to you. Happy birthday. Are you
All right, did y'all notice the next day? Check the next set of questions.
Oh,
7 through 12. Now, things like number 8, if you have the double bond on the other side, and you have a single bond here, I would not take off of that. So like on number 8, if you did now, if you flipped it and then a double bond of number 8 like this, I would not take off of that. Okay? If you put the double bond on CL and the single bond on O, these are called what again? What did we call those yesterday? They had a different name. Start with an R. Resonance form. I would treat either one of those as being the same. You just put double bond on the other side. It's fine. They're one and the same. So what? It is. It's not yours. Nobody. I'll just not take them if you forgot.
My great uncle died. I don't like it.
All right. Let's turn the last two.
Yes. What? No.
Becky's good at that. I'm a dog guy, she needs to go. Like today before Thanksgiving. I'm not playing with them, I'm playing with them.
You have your name, you have fun. Why are you doing this?
All right. Everybody got it?
Yeah.
Okay, last two.
Oh.
Now, Alexa, you're going to tell me what the issue is with the line. I don't understand your question. Explain to me the lines before. Okay? If you need them to get 8, you would add another line to 10 on the molecule. So if you drew something like PI3, for example, I don't know. So if you had 12 electrons, for example, and you drew in, first of all, they have to share 2 electrons. So you could draw one line, right? Because you know they're sharing 2. So you drew in 2, 4, 6, 8, 10, 12. So that's your 12 that you counted up you drew in. All right, does everyone have 8? No. So you're going to have to fix that. You can't just go, oh, boom, boom, and say, now everybody has 8, because that has 14 electrons, and you said you can only have 12. So all you can do is shift electrons and rearrange what's here on the board. So all we do is move electrons. That's how you decide you need another line. So that's right, we're moving these. These 2 that were right here, we're moving them literally from here to right there. That's how we get the other line. We're just moving them. That's where the other line comes from. But if you draw one like the one we drew on the other page, PI3 had 26 electrons. Well, 26 electrons, when you draw them in, everybody winds up with 8 when you draw them in. So, right. So when I draw in the 26, does anybody not have 8? Everybody has 8, right? So since everybody has 8, do I need to rearrange to try to come up with another line? No. So we don't draw another line in this case. But in this case, everyone didn't have 8, so I had to draw another line. Okay, that's the difference. Does that help at all with the line? Okay. Now, who has a question about how we drew one and you didn't know how and you need an explanation with that? What was number 6? The SBR6? Okay. So when you added up SBR6, you had how many electrons? I was going to say, I thought it was 48. Okay. So S had 1, BR had 6, times 6 electrons, times 7 electrons, then you get 6, you get 42, for a grand total of 48 electrons. Okay? Central atom is F. This is going to be what we're going to call today an expanded octet. Okay? So you're just going to draw 6 BRs around the sulfur. Why? Still doing it the same way. 1, 2, 3, 4, 5, 6. And then there's 12, 14, 15, 16. Just keep counting until you get to 48. Fortunately, I know how they're going to look, so I don't have to keep counting. So it will look like that when you finish. Okay? Oh, you didn't have enough electrons. Okay, that'll do it. Queen. Uh-huh. Around the SI, yes. Yes, they all go around the central atom. Mm-hmm. Which one are you doing? I thought I had 3 CL. Yeah, 3 CL, 1 BR. All right, what else? You will see some today. Anybody else? Just to make geometry go faster, I even did part of the note.
Amazing.
I know.
We like to draw.
I mean, like I ran them off.
You are a dick.
You don't get it already.
Yes, I wrote, and I.
Oh, I thought the Johnson is the national planet. I love that man. Yeah, I never had Johnson. Yeah, I'm sorry.
Alright. Now, for those of you who like titles, write geometry at the top. For those of you who like titles. Not all of it is ran off. I only ran off the chart piece. Now, I did not run off all of it. I'm not taking a leaf on my pen. It still appalls me that I ran off the chart. However, you know what have flow, that's how I was trying. I didn't want to be here the rest of our day taking this job. I'm not picking on you, but I want to get through. So, yeah, I know, because I talk at the same time, right? Alright, so, we're going to talk about valence, shell, electron, pair, repulsion theory. Now, because that is a mouthful, we generally just call it Vesper theory. Valence is B, shell is F, electron is E, pair is P, and repulsion is R. Okay? You talked about repulsion, most likely in elementary or middle school. Repulsion means to push away, right? So, electrons have what charge? They're negative, right? So in a compound, since they're negative, they will try to get as far apart from each other as possible, since they repel each other. They don't like each other. If I'm negative and Emma's negative and we're both electrons, we don't like each other. He's going to push, I'm going to push, we're going to push apart. That's what it says. It don't work that way. It's got to be positive and negative. Yeah, the sound and sound would also push apart. Same concept. Well, remember I still be teaching some sound test Monday. Yeah, sound test Monday. I hope not, but it is entirely possible. It will be recorded on YouTube. I cannot fix it. I cannot fix the field trip. Guys? I cannot work with, I can't fix the holiday, I can't fix where we fall in curriculum, can't fix any of that. Okay? If you don't take it Monday, I am not staying Monday after school or Tuesday. It'll be after the holiday break before you make up the test. I will not be here next Monday or Tuesday after school. Okay? I'm just telling you that. Okay? So if you don't take the test with us on the normal time period, it will be after the break before I'm available. I don't mean to be hard to get along with, but I'm here a lot of afternoons. Next week is a short week. I'm on holiday break too. No, we do not. We're a salaried employee. And I stay a lot compared to a lot of folks on the staff. Yes, they do.
I know, they sometimes make me before. I don't know, right?
I only do that on Friday.
So quick.
All right. Now, due to an atom's arrangement, each compound can be identified by geometry. Okay? So, based on where I position myself and where Emma positions herself on an atom, we can have a geometry. Geometries are going to be determined by two things. Okay? Geometries are going to be determined by two things. They're going to be determined by where the atoms are and where the lone pairs of electrons are. Now, does anybody remember what I said a lone pair of electron was yesterday? The ones by themselves. What they look like in our Lewis structure.
No, it's also.
Oh, that's the dot.
They're the dots. Okay, that's all I need you to tell me. The lone pairs are the dots. Yeah, you said the things that were not.
I said it.
Okay, dots.
And then I heard silence, I was like, that's not right.
No, it was right.
Oh.
That was exactly right. Okay? The geometries will be determined by where the atoms are and the lone pair.
It's like words, like you talk words about all
Yeah, whenever you write, you say what word, writing it.
Skills that a child can never get will help you tremendously in their education. One that you don't have that will help you.
And he goes really fast, I'm the friend. Okay, so what do I get? Yes, I don't think you.
We would have, we would.
I mean, everything on the board.
All right. So the chart that I'm going to hand you is going to have two things on it. And these are the things you're going to have to memorize, which is why people hate geometry. Okay? So, to determine the geometry, what are you going to have to find about the molecule? After you draw it, you're going to have to determine or know two things. The number of atoms on the central atom. Hey, what's up? I thought about that yesterday. I was like, wait till I can get me back.
Can I have to call an administrator, somebody to go back?
Yeah.
Yeah.
Hold the hands of you.
They get
Drinking can.
No, seriously.
I don't know if it was lifted because they caught the person, apparently, who did it, or if it was not lifted, and they still can't go to the bathroom. But apparently some kid went berserk in the bathroom in the annex building, ripped the sink off the wall, ripped the pole off, or pipe off, dumped the raisins down the sink at the toilet, and now none of the guys can go to the bathroom.
But they caught the kids, but they still got a lot of hands.
Are you sure? Well, I'm not sure anymore.
Yep.
Some of my report periods said that they had lifted it, some of them said they didn't. So I don't know. We never got an email or any clarification. So I have no idea. I thank you for that.
I thought you were talking about.
Yeah, I'm worried about that every report period. I'm like, wait till Rachel goes back and here's that. Thank you. I received that today. Okay, so you need to know two things. Because she's the only person I know who's right here beside me who lets it go freely. So that's cool. All right. So the number of atoms, and you have to know the number of lone pairs. Now, notice what I have written right here. This is the key. It's not just the number of atoms and lone pairs. They have to be where?
On the central.
On the central atom. So you're not counting all lone pairs everywhere. You're counting them on the central atom. Okay? That's the important thing. Where are they in relation to the central atom? Now, normally, at this point, we would draw a chart. So catch up with me. Now, I'll show you what we normally do. Huh? It'll decline rapidly about 11:40. Why do others look uncomfortable?
No, my.
Yes, and they could, and they usually are gonna form it sandbox here, and they're not gonna form them with, I think they usually form a square pointer and another geometry that's not really one. That's what you want. If you don't, if you got an AP or a second level, yeah. Because there are other standard geometry sections. I'm only teaching you sandbox. There'll be no sandbox section. I'm just elected to teach it. There are others I could teach, but I'm just not. All right, everybody caught up? So normally at this point, we would draw a chart. Don't have to write it. All right, and I would explain where the geometry comes from based on these things. Now, I'm still going to do a little bit of this to explain the chart. Otherwise, some of you will drive me crazy. So you can write on the chart because this is yours. These are your notes. You cannot use this on the quiz or the test. The information on the chart you must learn. Okay? Normally, you would be writing it down in your notes. I'm just trying to make note taking a little faster. Okay? So that some of us can listen instead of writing on. Okay. So, for example, if you look at the top, you've got the 4 columns that I have right here. If I draw CO2, I'm not going to explain where the Lewis structure came from. It's just the Lewis structure at this point. Now, if I ask you what the central atom is at this point, you should be able to tell me the central atom is what else? Carbon. Everybody good with that? How many atoms are coming off the central atom of carbon? Everybody good with it? How do you figure it out? Because some of y'all are just staring at the piece of paper like, what's he talking about? There's 1 oxygen here and a second oxygen there, even though my 2 looks really bad. All right, 1 oxygen, 2 oxygen. Is everybody okay with that? We got 2 oxygens. That's how we get the number of atoms on the central atom is 2. Is everybody good with that? Now, those are the atoms. Okay, we're not counting bonds or anything like that. We're counting atoms. So there's 1 oxygen, there's 2 oxygens. Now, the number of pairs on the central atom refers to the number of lone pairs. Okay, I think I actually typed lone pairs on there. Yeah, because I had more space. So lone pairs are what again? The dots. So who is my central atom? So how many dots do you see on the C? So what do you have to learn? 2 and 0 means the geometry is what? Linear. Now, why is it linear? Because if we connected from this O to this O, it would be a what? It'd be a straight line. Okay? That's why it's called linear. Now, you also have to know the bond angle. Bond angle's not on your chart. You need that. The bond angle from here to here would be what in geometry class? 180 degrees. Oh, I wrote it on there?
Yeah.
Whew, I was forward thinking, wasn't I? Way to go, Miss Wall. Now, I don't care. They're your notes. I told you to write them anywhere you want. Now, if you have something that has no central atom, for example, chlorine, which is diatomic, you have no central atom there. It's just 2 atoms written side by side. Okay? Well, what is geometry be? It's still in a straight line, so it's still linear. Okay? All right. Now, if you have something like old board for dots. like this one.
How
How many do we have on the central atom? Gotcha. How many atoms on the central atom? How many lone pairs? How many lone pairs? Dot. Dot for lone pairs. I know that. Some people are still yelling 3. Okay. There are how many atoms? How many Y's? Okay, that was the 3 that people yelled, which was fine. Then I said, how many lone pairs? And people are still yelling 3. The lone pairs are the dots. How many dots do you see on this X, which is our central atom? There are no dots, right? That's why there's no lone pairs. Lone pairs are dots. So on the X, how many lone pairs do you see? 0 lone pairs. Yes, I'm doing all the ones without lone pairs first. But I will do one with a lone pair next if you would like me to. Okay? I just want to explain where the geometries come from, because I think it's easier to learn them if you're not just learning, 3 and 0 and they're abstract.
The number of atoms in a central atom is referring to what surrounds it.
Yep. There is. Yeah. Oh my God. Got it right. Not tomorrow. I can pay you.
No, I saw.
The good news is, when do you have me tomorrow?
Oh, lab. We have to choose lab. Wait, what do you mean you got to choose lab? We have to.
I can't.
I
thought it was a thing.
Looks like there was top door.
I can't read.
I know I'm doing
What I'm gonna wait is that hearing the first thing, and we have to get that's how 40% of our jury. No. Why do I never find these things out until the day before?
Tomorrow we have a flip schedule.
They do know.
The flip schedule we're going to tomorrow is 4th period first, then I think we're going to 2nd period, then we're going to 3rd period like normal, then we're finishing in 1st period.
We got
No, that's so.
All right. This is the structure, guys. You got geometry and polarity tomorrow. We're down to 40 minutes. Quick to run off. We're taking it tomorrow, whether y'all can do it or not. Keep going. Now, you have 3 atoms and no lone pair. The geometry is based on this shape. If I connect all this, what am I going to wind up with when I connect all this? Well, it's called triangular. Now, you cannot tell me the geometry's name is just triangular. All right, because there are 3 of them. Now, this one lies flat in the plane of the board, so it's called triangular planar. Okay? Yes. What will what look like? We're not there. Stop asking me what the quiz is going to look like. Let me teach, and we will get there later. Y'all lose a ton of time asking me stuff like that we don't lose 4th period because I can teach. Okay? So stop badgering me about a quiz. Yes, please. Yes. It's not going to be planar. They're not going to call it planar if it's not flat. For example, the next one's not flat. So if you drew something like, let's just say CCl4, you guys are going to draw this way. And you're going to label it like this. And there's nothing wrong with that. I will take it every day of the week. But it looks like the bond angle could be what if you drew it like that? If you were sitting in geometry class, you would say the bond angle along this or what? 90 degrees. And it's not 90 degrees because that would be flat. Are molecules flat? No, they're not. So, if you look at what I drew on your piece of paper, I probably did draw it both ways. I did. Okay? The molecule really only has two that are flat. These two are flat, and then these, one of them actually comes out in front of the board, and I'll build this molecule in just a second. And then one goes behind the board. Okay? And they still all have 4 dots on it also. And I will pass it around if you would like. But it's going to have one that comes, another one is blue. All right, 2 that are flat, that lie in the plane of the board. Okay, so these 2 are flat. But then you have one, see how that one is sort of sticking out in front? Okay, that one. That's not flat. And then you have one that's going to stick out the back side of it. Okay, so only the blue ones are flat in the plane of the board. This one sticks out in front, and this one sticks out in the back. Is this a 90-degree angle? No. This bond angle here is 109.5. Okay, so how many different atoms do I have attached to it? I have 4. So 4 and 0 is tetrahedral. Tetrahedral, and it's written on your sheet. Okay, everybody see that? Now, and the next one, right, really the next 2, are your 2 that are beyond the norm. They're your expanded, I think I labeled it on the sheet, the expanded octet. Okay, so both of these are going to have more than 8 on the central atom. So if you have something that has 5 coming off of it, all right, 5 and 0, and then 6 and 0, you're going to have these. And I can easily build those. All right, so we start at the first one. What's this look like again? All right, so the 5 and 0 starts as a triangle. That's one reason you can't label it triangular. Okay? If I connect this to the top, I connect it like that, well, I get pyramid. And I connect that, well, I get another pyramid. So 5 is a common way to say what in math class? 2. So we have 2 pyramids. Okay, that's why we call it bipyramidal. All right, the octahedral is very similar. I'm not going to worry about the colors because it doesn't matter. And that's why I brought it. Now, why is it called octahedral if it only has 6 full sticks sticking off of it? All right, if I had a piece of paper, it would go through here and here. How many quadrants do I have on the top? 4. How many quadrants do I have on the bottom? So there are 8 quadrants on top, and how many quadrants on the bottom? 1, 2, 3, 4. There are 4 quadrants on the bottom, and how many quadrants on the top? So there are 8 quadrants. It's not about 8 atoms, it's about 8 quadrants. So you would need a piece of paper to like be able to go through here, another piece of paper to be able to go through here, so you could divide it, okay, so that you could cut it up into squares. And I can't do that, okay. There would be 1, 2, 3, 4 quadrants on the top, and then on the bottom there would be 1, 2, 3, 4 quadrants on the bottom. Okay, does that make sense? All right, so 6 and 0 is octahedral. Everybody okay with the ones that have no lone pairs? Okay, now the ones that do have lone pairs. All right, so if you have something that looks like this, Okay? How many atoms are coming off the central atom? How many lone pairs? Okay, you see that dot that's right there on the central atom? It looks a lot like linear, doesn't it? What makes it different from linear? It has those dots. Same thing if you have this. Okay, this time you have 2 and 2. They both look linear. They both have 2. They both have 2, except both of these have what on?
Kind of looks like, if you were to draw lines, it would kind of look like the mitosis thing where you had like you have two atoms.
Yeah. The only thing that makes these different is they look like this. Instead of a straight line, they look like that. That's better. That's better.
Can you
Okay?
give us the definition?
It's an electron not involved in the bond. I wrote it in your note yesterday. Look back at it. Mm-hmm. They're not involved in the bond. These are involved in the bond. These are not involved in the bond. That's the only difference. And you wrote them in your notes yesterday. Okay? If you look back, it's there, but you can write it again if it makes you happy. Say what? I just didn't draw it that way. Some of you will be like this and draw it that way. Some of you who drew it in your homework probably drew it this way. Same way. It doesn't make any difference. Because you guys don't know the geometry, I would take it either way. Some math teachers would argue you're just looking at it differently spatially to draw it that way and that way, depending on the plane that you're looking at. As long as you can draw it that way and tell me it's bent, I don't care if you draw it that way. As long as you can tell me it's bent. Okay? 2 atoms and 2 lone pairs. Okay? So the last one that you would have to be able to do has 3 atoms and 1 lone pair. So the only difference here is, again, it has 3. So anything that has 3 is in what shape? That's right. When you connect it, you get a triangle shape. So triangular. And this time you only have one what? One what? Yeah. So triangular pyramidal. If you want to sound really smart, you can say pyramidal. Okay? Now, find homework. All right, find homework. You're telling me geometry. You have to draw it. All right, go to question 1. It has no central atom. It says I bond between I. So what's the geometry? You've got no central atom. All right, jump down to number 4. What's the central atom? How many lone pairs? How many atoms going around it? So what's 3 and 0? Triangular planar. Jump down to 10. What's your central atom? All right. How many atoms coming off of it? How many lone pairs? What's the geometry? Do the rest of it. You got it, Alexa?
That's why. Okay. What number are we on?
I looked at the rest of it. I went over 1, 4, and 10. I mean, atoms you got? How many lone pairs you got? So what does it do? Got it? So as you draw this wall, you'll have to come to count. All right, so drawing this, so like this. How many atoms you got? How many cylinders you got? That was 8. I was 2. Who was 2? What's the geometry? Right. Yeah. Right. Hey, what? You better learn that.
What if I have a picture?
We're gonna do triangle and circle.
I know for sure. My picture is a picture. That's where I'm at.
The good part for you is each question, each Lewis structure, each geometry, each polarity is a separate question. So if you misspell everything, you can get to the Lewis structure in your question.
You can tell it like that.
You'll do that too, you don't know how to spell, so you do like the first 3 and then just have a squiggle and hope you can keep your
My side.
Oh, man.
I don't give you credit for that.
I do
I
that.
mean, you can do that, but I'm gonna let mine.
I mean, that's how right goes.
I don't know, I thought you like, you do some, they were small. You're like, what is this?
I have to hear people before series try that with, some of those names in the I think they're answers. Lanthanide, actinide, I don't remember which one it was, but I didn't get the name.
That's different.
No, it was calculus, that's what it was. Y'all got all that wrong. They actually attempted it because they knew the name of group 16 other than the oxygen family, other than they couldn't spell it.
Hey,
So a lot of them just got it wrong because they couldn't spell it. They had CH, that's all they had to put.
I had it.
I did that.
I had it. I did on my paper. All I saw was I didn't see the C. That's all like that.
I had to go on my window, and I went back to like, you know what? Up there, I just, yeah, like, I was even cross from, like, I was looking at the front of the ocean, I was sitting there, right by all the answers to the letters. It's okay, I didn't even know I was taking this test.
Oh, there's no gravity goes tomorrow either.
I don't remember hearing.
So what?
No, I'll probably get pushed down my desk.
Oh, that's right.
If it's off just slightly, I will take it. If it's off a lot, I won't.
No, I really.
So that y'all are informed, they hope the schedule will not be shifted time-wise. However, if testing goes over, you will have to stay in for slightly longer than usual. Just telling you. But fourth and first are switched. Second and third, they were they're supposed to be. Fourth and first are switched. No grab and go tomorrow. So if you want breakfast, you have to eat it in the morning. Okay?
Oh,
I mean,
I might because my class, my book is like right here. I might be there.
You're walking.
Oh, that's wrong.
Oh, yeah.
Right?
I didn't know you could.
I'm like, oh.
Does not say in the email whether or not you guys still need. That question has not been answered. All right, so if we look at the homework.
No.
What?
I'm not done.
Okay, well, hurry it up.
I'm almost done. One more. Okay, I'm done.
Okay, so number 1. What did y'all choose for number 1? Linear. What did you pick for number 2? Linear. Number 3. Triangular planar. Number 4. Triangular planar. Number 5.
Oh, I didn't see that.
All right, since we have some disagreement. How many O's do we have on number 5? How many lone pairs on number 5? 2 and 2 is what? Then. All right, number 6. Octahedral, good. Number 7. Triangular pyramidal. Number 8. Bent. Number 9. Good. Number 10. Good. Number 11. Good. Number 12. Good. Number 13 and 14. Question. Now, tomorrow you will draw the Lewis structure at that time and then tell me the geometry instead of already having it drawn for homework, then tell me the geometry. Nope, get ready to teach that one. Huh? Nope, haven't learned that piece yet. Yeah, not done yet. Nope. And I still have 20 plus minutes. All right, for those of you who like title, write polarity of a molecule. I'm going to erase that in a second, but that's your title, since I shorthanded it on the board. All right, but that's your title, polarity of a molecule. Very new. I'm just happy to claim. Considering the rest of my day, yes. Yes. We can accept Dr. Children's teacher since she's a lot of project.
I saw it hard.
You saw it dark.
Yeah, and I more up and down, I've seen it somewhere.
She does. That's Miss Hathaway.
I really want to hear so many people calling it the rooms and stuff from guidance. I'm like,
All right. So, bonds can either be polar covalent, ionic, or non-polar covalent. Now, we determine bond type using an electronegativity scale. Now, this is review. Type of bond. 4.0, 1.7, 0.3, 0. Oh, and in case you haven't looked at the entire store recently, your live grades in there. I haven't have today.
Oh, that's what it was.
Live grades are in, switch grades are in. Okay, those are in.
I mean, then you've got something else.
If I have time today, I'll hand it back.
Okay.
Now, so this part is review when I say type of bond. Okay, this is the part we've already done. The part we had the quiz on yesterday.
I know.
Oh yeah. You were at
No, I didn't miss it, but I missed learning.
Oh, okay. Gotcha. For example, if we had CCl4 yesterday, you would have done what? 2.5 subtract 3.0. You'd have gotten 0.5, and you would have said it was what? Polar covalent. Guys, everybody's good with that, right? Based on yesterday's quizzes, the vast majority of you are good with that. There are a couple spots we need to work on, but most people are okay with that. Now, we got to take what we know there, and we've got to branch out, okay? We've got to take what we know, and we've got to become more sophisticated. It is possible. Now we want to consider the whole molecule, not just one itty bitty bond. Okay? that's supposed to have substrate before. So what would happen to its polarity if we considered all 4 bonds? So instead of just considering 1 bond, we're going to consider all 4 bonds. Okay? That's where it's going to be different now. Oh, I was attacking. No, I didn't, but I can't hear over the piano notes. No, I just had that problem with somebody. So I don't. All right. So the easiest way to do this is to talk about how to be non-polar. Okay? Rather than talk about how a molecule can be polar, the easiest way to do it is to talk about how to be non-polar. Okay? So, in order for a molecule to be non-polar, you have to meet 2 requirements. If you don't meet both requirements, you're automatically what? Polar. Okay? Everybody with me on that? That's right. If you fail to meet either one, you're automatically a polar molecule. And these are not difficult requirements to meet. It shouldn't take us a lot to understand that. More polar. It's harder to be non-polar. All right. The first requirement. All dipoles are equal. Dipoles is a really fancy word. Basically, it means their difference in electronegativity is the same. Meaning when you subtract the 2 numbers, you get the same number. A dipole is just the difference in electronegativity. So you see how we subtracted 2.5 and 3, and we got this 0.5? That's a dipole. Okay? So their difference in electronegativity is the same number. That's a dipole. Yeah. If you didn't have to say no. You know how you had that SiCl3 and Br? And you had 3 SiCl bonds and 1 SiBr bond? That's not one and the same dipole. Okay. Well, I'm going to show you some examples. Relax. Chill. Relax. Don't get upset over that. I'm going to show examples. Okay? Because if they're already getting worked up, I'm worried about you a little bit. Okay, we all keep your energy to yourself and stop upset the left. Not necessarily. Not necessarily. Not necessarily. All right, the last one. Give me a chance to show examples before you get your panties in a wall. Okay? Now, you want to see a bad word, y'all just want to throw my phone. All right. All dipoles pull in equal and opposite directions. Now, that essentially means the bond angles are equal. Well, how are you going to know if the bond angles are equal when I didn't teach you all the bond angles? I'm not going to make you know all the bond angles. I put, what, 3 on your sheet? So, the bond angles are equal if there are no what? No lone pairs. Now, if I say there are no lone pairs, where are the lone pairs that are important? On the central atom. So if there are no lone pairs on the central atom, then the bond angles are what? Equal, and the dipoles are pulling in equal and opposite directions. So you're essentially checking for 2 things. Are the dipoles equal? And are there no lone pairs? If you have those 2 things, then it's non-polar. Yeah.
I'm sorry, so it's just, so basically the word is from 1 to 12.
So you can another one. Sure. Yeah. You're okay. We do this. So, if we look at an easy one, like the one I just gave, CCl4, and I ask for molecule type or molecule polarity. Growling will not help. Okay? I often feel that urge later in the day. It doesn't help me.
Like around 11:40.
Around 11:40. My students keep asking me why I'm in a bad mood that time of day. They don't understand. They're like, yeah. They're like, why are you always in a bad mood, Miss Paul? I'm like, I don't understand.
You're supposed to be, why are you always in the house?
I just tell them that I don't understand.
You got pop up.
You got 5-star bed brain ribs? That is so sad.
Okay.
So, CCl4. Maybe you ripped the sink off the bathroom wall. Alright, so CCl4 has 32 electrons. Okay, so who's my central atom?
C.
And we're going to draw 32 electrons around the Cl. And I'm just going to draw it for the sake of time. Okay. Now, we can do this with our electronegativity chart if you'd like. There's nothing wrong with using our electronegativity chart. Lots of you will like to do this. Okay? I don't personally prefer to do it that way, but it's up to you. Now, if you like to use your electronegativity chart, we can look at C and Cl's electronegativity. And C is 2.5 and Cl is 3.0. So the difference here is going to be, now, because Cl is the more electronegative atom, we draw the arrow towards it. And we put a plus sign through that because C is what we call more electropositive. And then we put 0.5 on it. This is more electronegative. Bigger number. And you would just draw the arrow going that way. To the smaller number. That's all. The plus goes to the bigger, the arrow goes to the bigger number, the plus is at the smaller number. Doesn't matter which way it points. Okay? And then you write the number on top of the arrow. That's it. The arrow points to the bigger number, the one that's more electronegative. Okay? The smaller number we call electropositive because it's a bigger, or it's a smaller number. Okay? I'm just giving you some vocabulary, that's all. Are you going to see it tomorrow? No. Okay?
But you're not going to do this.
We do this. I'm not going to ask you to label electronegative and electropositive. You are going to have to be able to figure out if it's polar or non-polar. Okay? Now, can we agree that this bond, this bond, this bond, and this bond are all the same? So we can agree that this is a 0.5, this is a 0.5, and this is a 0.5. Okay, so the two rules were the dipoles were the same. Okay, is everybody with me? Yeah. Dipoles are the same. There are no lone pairs. That's where I got that from, right? Okay. I didn't make up anything. I just wrote down the two rules. So when we look at this molecule, what can you tell me about the dipoles on all four of these bonds? Are they the same or are they different? Do I actually have to subtract to get that information? No. What can you tell me about the bonds? Are they the same elements or are they different elements? So do I need the numbers to figure that out? No. You can do it if it makes you happy.
What if they're the same element?
If they're the same elements, they're going to. Okay. Okay, so the dipoles are the same. Do you have any lone pairs on the seat?
No.
What kind of molecule is it?
Wait. No.
If you meet both requirements, it is
Non-polar.
I think it's
is a non-polar molecule. Okay? Now, feels that way to me too sometimes. Not many, but today feels that way. All right. If we have water, not one of my favorite units.
Not my favorite to be. I don't like those.
All right. If you have water, like this, we're not going to use the electronegativity chart this time. Not going to subtract. Okay? Are my dipoles the same? What can you tell me about this bond and this bond? Are they the same bond? Is this an OH bond and is this an OH bond?
Yeah.
So if we look the numbers up and subtracted, would we get the same difference here and here?
Yes.
Then the dipoles are the same. Okay? But what?
There's one more on there.
Okay. So, do I have lone pairs? So, it's polar. If it was one or both, it's polar. It is balanced.
Polar bear.
Yes, Alexa. Huh? Because this is an OH bond, and this is an OH bond. If we looked up the numbers and subtracted, because they're both oxygen and hydrogen, when we subtracted, what do we know about the number? It'd be the same. That's how we were able to say they're the same. Now, you could actually subtract if it makes you happy, but you know you're going to get the same number when you subtract. Okay? Yes. So if you had one, and I'm not going to draw all the dots here. What can you tell me about the dipoles without ever looking up a number? The dipoles are not equal. You can automatically say no there, and you can automatically say polar, because these bonds right here is different than the other three. It's automatically polar. You don't have to go any further. Okay? No. You will not have to know angles. Now, last one. Almost. What do you do when there's no central atom? What do you do when there's no central atom?
Automatic.
Pray. Well, you can certainly pray. There's nothing wrong with prayer in school. As long as we have quizzes and tests, there will always be prayer in school. It's in my class. Go ahead.
All that, y'all.
It's, would it be non-polar?
If you automatic not polar.
How many bonds do you have? One. What do you do? You would subtract the what? Electronegativity and see where you fall on the scale. Okay, so you would have what? 2.1 and 2.8. So 2.1 subtract 2.8 you get 0.7. So this would be what?
It'll be,
It's 0.7, not 1.7. 0.7. Now, I want to alter the direction on this. Okay? We've got, make sure we understand where we're at. The first column, you see how it says bond type? What do you do for bond type? Covalent, metallic, polar, non-polar, covalent. What are you doing to do that? Electronegativity is subtractive. So if you don't not gonna remember it, make yourself a note. The middle column. Guys, remember geometry right there? If I check this tomorrow, I'm looking to see the geometry and the Lewis structure in that column.
So like we struggle with stuff.
And then label it geometry. Out in the far column, see where it says molecule? I'm looking for polar and non-polar. On the back side, see where it says short answer? Get rid of all that. I only want you to do the short. Okay? And answer that. Do everything in the chart. Stop at the chart. Where's that short answer down here? Get rid of that short answer stuff. Just doing the table. Front and back. But just the table. Okay? Then you have makeup work. I'll be here again this afternoon.
Well, when you think makeup class, we could.
Sometimes they take periods.
Okay.
I didn't have the tea with me last night. I was reading all those questions. Those of you who want the breakfast fast, come get one.
Can I go to that door and talk to you first?
Yep.
Okay, I don't want to walk in the hall.
No. Here's the child.
Yeah.
Get the baby bar.
I figure out.
Oh, that's funny, no. What's your problem? That's funny. I bet you learned that in anatomy.
All right, Quentin, have a good birthday. Did I get everybody who wants one?
Yeah.
Okay. Bye, Emma. Let's try to relax. You need a what? You tell me that every day or almost. You need to relax. You're fine.
Cindy Gomez, please come to the main office. Cindy Gomez, to the main office, please.
Bye. Disney Lee.
Final children, bringing time. I think so. I mean, right, right. Well, I think that's right. But then, read that, then you go back, sometimes you go through. And another thing is that I don't know how to prevent that. Right. But they need to. Yeah, well, what I'm trying to say. Okay. Right. Exactly. That's not my job. No. Well, those involved, there's no way around it. Well, I don't know what that's in Wanda, and they're always coming other ways to well, well, that's fine, but I can say, I don't want to see that. Wait, number one, oh, right, anybody, problem. I don't think that's it, right? But, I mean, I think that the source code guidance is helpful. I mean, I think you totally look at it. Look, I didn't. I said, I did those. I mean, short of being something up to or a guidance, how long got say, it's not, don't worry about it. So I are not. Exactly. I'm of that. Now, I can do like some people, be always all day long. There's something to do. But when you sent email, it wasn't that you sent me. But I don't. But I want to get these. Well, that was, I don't know, a lot of times you get happen. I know a mom died. I hope it was something, I don't know if it's something bad, I guess it's been on something. No, I haven't seen it, so I don't know. It's not. Okay, this might be. Okay. I have not seen it, so I don't know. Last time, we had the football, that's happening. They call stop eating everything from all the guys, but I'm telling you, it wouldn't last. These girls, male, no, I have to. Yeah, but I can't make my habit, and so I did, but I mean, and I even kind of knew, what was happening. But, I just think it's a great idea, but I just, but anyway, so, yeah, I was in my work. Well, you be better than my class. I will, I'm better than you. No, that's it. Well, I'm not. Don't smart, but the thing about, I'm the nurse is not gonna. But I think. But they don't even do that.
Oh,
Third, I really don't. So, but I thought you did it. Well,
Don't
it will be, I won't, but it'll be on the smart board. You just walk in and say, you just. It'll be fine. I didn't go wrong, yes. And
I'm just gonna give the copy.
even, I thought that. So, we couldn't get in my, they're like, I said, "Would you like that? That's what you do for this." I said, "Oh, no, I did all-"
I would have known that if they'd come and got me. Because it's articulation 101. I knew that. Nobody
I'm
knew
gonna
that.
talk to your teachers. Grab and go is now over. All students should be in class.
I was like,
Grab and go is now over. All students should be in class. And students should be using their grab and go in the classroom.
Yeah, I had that. I might have done through the plans and then I see me. I realized there's a problem. No, he wouldn't. I don't know.
Or he had the phone number, well, no, he didn't, but he didn't have the number.
No, but I had the phone number. Yeah, I know. Yeah, if somebody just come to ask me, I'd have figured it out.
All right. That's right.
I'm gonna turn this thing off. I have to do. No.